Okay, this is Jiangling Pan, and it's a video for ACE 6303 homework 10, question 1. Okay, question 1 says we should collect the definitions and simple properties like probability mass function or density function, mean and autocorrelation function of the examples of stochastic processes. We have 7 sub-questions. Okay, let's come to the solution. The first one is Poisson process. We knew that the Poisson process we have in this time interval t1 to t2, we have the Poisson process. We have n, the random variable n equals to k, and the probability for n in the interval t1 t2 equals to k should be e with the power of minus lambda tau, and multiplies with lambda tau's with the power of k over k's factorial, and tau equals to the absolute value of t1 minus t2. Okay, the second sub-question is called Poisson increments. And we have the definition is as follows. We have 2 time intervals, which is t1, t2, and the t3, t4. And if t1, t2, and the t3, t4 are not overlapping, and t1, t2, and t3, t4 are independent. Okay, Poisson process, we have the mean expectation for me, or the mean of xt equals to lambda t, and the autocorrelation of Poisson process is lambda squared t1 t2 plus lambda minimum t1 t2, and the autocovariance function of Poisson process is lambda squared t1 t2 plus lambda minimum t1 t2 minus lambda squared t1 t2, which is as a result lambda minus minimum t1 t2. Okay, the second sub-question is a Poisson increment process. Okay, the definition is as follows. We have a yt equals to 1 over epsilon multiplies xt minus epsilon minus xt, where x of t is a Poisson process. Okay, the first order probability mass function yt equals to n over epsilon equals to e with e powers lambda minus lambda epsilon, and lambda epsilon with power of k with power of n over n's factorial. The mean is lambda, and the autocorrelation function is when t1 t2 t1 minus t2's absolute larger than or equals to epsilon, the autocorrelation function is epsilon is lambda square, or it's lambda square plus lambda over epsilon minus lambda t1 t2 over epsilon square. Okay, the third is Poisson impulses. The Poisson impulses is the derivative of xt, which in which xt is a Poisson process. It has a mean of epsilon as a mean of lambda, and the autocorrelation function is lambda square plus lambda delta t1 minus t2. The autocovariance function is lambda multiplies with delta t1 minus t2. Okay, the fourth is semi-random telegraph signal. It has a first order probability mass function. P n equals to k is is sort of the same as the Poisson process. Okay, and we have an xt equals to 1 when the k is even, and xt equals to -1 when k is odd. So we have the probability function, mass function is p. We have xt equals to 1, which is like this, and xt equals to -1, which is like this, and the mean is e minus 2 lambda t. Okay, the fifth is like a random telegraph signal, almost the same, but however the e equals to 0 and r equals to r. It looks like that's the same. The sixth is random walk. Random walk is like we toss a fair coin n times, and k is the numbers of heads in n tosses. We have x and t equals to ks minus n minus ks, which is 2k minus n multiplies with s, and the probability mass function is like this, and the even is 0. Okay, okay. Thank you.